Okay, in this video, we're going to continue our discussion about angles, and we're going to talk about complementary and supplementary angles as well as vertical angles. Okay, set of complementary angles is two angles. Okay, when you add their measures together, it equals 90 degrees. It becomes a right angle. When you talk about so if I had two angles of 60 degrees and 30 degrees, 60 degrees plus 60 plus 30 gives me 90. So those two angles would be complementary. They don't have to be next to each other. They can be on two different diagrams. They can be anywhere that you want them to be. As long as their measures add together to give you 90, they are complementary. The same thing works with supplementary, except the part that you're looking for there is to add together to be 180 degrees. So you're looking at an angle measure of 120 degrees and 60 degrees, or 130 degrees and 50 degrees, or two 90-degree angles. 90 plus 90 gives me 180. 60 plus 120 gives me 180. 50 plus 130 gives me 180. All of those would be supplementary angles because their measures add to give me 180 degrees. So let's talk about, we've got our definitions. Complementary, two angles whose measures add to 90 degrees. Supplementary, two angles whose measures add to 180 degrees. So let's look at our picture over here and let's see which angles we're talking about that might work. All right, so I have an angle here that measures 55 degrees. Okay, so 55 degrees plus what would give me 90 degrees to make it? That would be 35. So that means I could use angle AQH, angle AQH, and angle HQG, HQG would both be complementary because these two angles, when added together, give me 90 degrees. Okay. Are there any other angles that could be complementary to angle HQ, AHQ? Okay. And yes, there are. So we have angle AQH, and what's the other angle? That would be angle DQC. Angle DQC, because that's 55 and that one's 35 as well. They don't have to be touching. They don't have to be what's called adjacent. We don't have to have that. All we're looking at is their numerical measures. Okay, so when I have angle HQG, is there another angle besides HQA that would be complementary to it? And yes, it would be angle EQD. Angle EQD. So those would all be complementary pairs, okay, for that. So then let's talk about supplementary angles. Supplementary angles, again, angles that are adding together to be 180 degrees. So let's pick one of our angles over here. Let's pick this one right here. I'm going to pick the 63-degree angle. Okay, so it's GQF. All right, I'm going to put this one over here. Angle GQF. Now it's 63 degrees. Now the easiest thing for us to do right here to find an angle that would match would be to take F to Q over to C, which would give me the rest of this straight angle. F to Q to C fills in the rest of that angle right there. So that before I go from G all the way around to C over here, which gives me a straight angle. So angle FQC would give me that supplementary angle. Hope that makes a little bit of sense for you. All right. Same thing would work on the top side. If I took this 63-degree angle, which would be angle BQC, QC, and then I'm looking for the rest of it, which would be that one right there, B to Q to G, B, angle B to Q to G. Now, hopefully that exemplifies that. Now, obviously, GQF is 63 degrees. Could I have used this one right here? Could I have used this one? Could I have used GQB as that one? Absolutely, because that becomes a straight line as well. So there's many different combinations that you could have out of this. The primary thing that you're looking at is looking at the numbers to make sure that they are adding together to give you 90 degrees for a complementary, 180 degrees for your supplementary. And now let's talk a little bit about vertical angles. Okay, vertical angles are formed when I have two lines that intersect. So I'm going to go ahead and erase this one that I have up here already. I'm going to very quickly erase it to give me a little bit of space on my board in order for me to be able to draw that. So I take two lines, any two lines, put arrows on the end of them because they go to infinity. Two lines that intersect, okay? This is their intersection point, okay? So that becomes the vertex of these four angles. It also becomes the vertex of the straight angle that goes there and the straight angle that goes there and so forth, okay? Hopefully you followed a lot of that. But, so we're going to call this M, N, O, P, and we're going to call the middle point Z, okay? So if that's the case, when we're talking about vertical angles, so these, the intersection of these two lines, this is angle M, Z, N, okay? Vertical angles, the only point that they share is the vertex, okay? The only point that they share is the vertex. When they're formed by two intersecting lines, the only point that they share is the vertex. So that means the vertical line is this one right here. The vertical angle goes there. So it becomes angle PZO. These two angles would be vertical angles. Now, I would also have vertical angles going here and there as well with that. And the other thing that you need to know about vertical angles is that all vertical angles are congruent, okay, or they're equal in measure. Think of a pair of scissors. When you open up your pair of scissors, the wider that it is between your fingers, okay, the wider the blades are on the other end of the scissors. And the angles on the outsides work that way, same way as well. They're working off that same axis in the middle, which is what my vertex is right here in the center. As this widens, this one widens, okay? And as this widens, this one would narrow. These two angles, angle 1 and angle 2, are vertical angles, and angle 3 and angle 4 are vertical angles. And if they're vertical angles, they have to be congruent to each other. They have to have an equal measure, okay? So complementary angles, two angles that add together to give you 90 degrees. Supplementary angles are two angles that add together to give you 180 degrees. Vertical angles are formed by two intersecting lines. The only point that they share is the vertex, and they are equal in measure. Thank you.